All right, everybody, nomenclature, continued. Ring, continued. Cis and trans, continued, except we're naming it. So, how do we number these things? Here's where we're going to get into. There's thousands of UPAC rules, right? This is an introductory course, right? I mean, we do a pretty thorough job. It's not like I treat this as like only the basics. No. To me, you don't get the understanding for pharmacy and medicine that you're going to need if somebody's watered down your organic chemistry. So we're not watering it down, but we're not teaching everything. I mean, there's people that have devoted their lives to narrower subjects in organic chemistry like nomenclature and things. To me, there's a rule that goes too far, and it's going to be illustrated in this first example. You can go 1, 2, 3, 4, 5, and you're going to get groups on 1 and 2, correct? If you go this way, you still get groups on 1 and 2. So with the rules I've taught you so far, there's not one better way or worse way because you both put a group on 1 and a group on 5, or 2, sorry. I hope that's the way it works. Yeah. If you got a 1 and a 5, then you pick the wrong numbering, period. In this course, I will accept the green or the red. For those of you who want to know the full truth, I'm going to mention it once, but I never enforce it because then I mention this little side rule, and then students think that's the big rule now, and they use it all the time. And it's never used unless there's a tie, like here. Okay, like a tie, exact same numbering system for where there's groups. Then you're supposed to pick the group that has a higher mass to be more important. It's the only time you would ever use mass. For me, I would rather you say mass is not relevant for nomenclature. I prefer you saying that because it's not about mass, okay? So I will take 1, 2 green or 1, 2 red. I'll give you both names. I'll tell you you're getting full credit for both names. So what's this group on 1? The green one. We'll do green first. CH2 6 times. What's that mean? Can I redraw the molecule? Those parentheses, when they're drawn like that, are really, they're your enemy. Get rid of them. CH2 once is right there. CH2 twice is here. 3 times, 4 times, 5 times, 6 times. We did that in black. We're going to do this in red. You need a new C that has 2 CH3s on it. That's what that is. CH2s in parentheses aren't like a CH3 in parentheses. CH3 in parentheses is sticking off of something. CH2 after CH2 after CH2 is a chain itself within the group, right? Don't you call this like a chain within the group? I would. Yeah. And then the top one, let's do it again. This is actually a CH3 sticking off of the previous carbon. So up there, we go CH2 once, twice. That one has a CH3, CH2 once, twice, CH3 at the end. You get no points for redrawing the molecule on a question where you're supposed to come up with a name, but it really helps you name it. Do you want to start with the cis or the trans? Which one is this one? It's a cis. They're on the same side. Green naming first. On 1 is this group on the bottom. It starts with the letter I. How do I know the group name starts with the letters ISO? Or 1, 2, 3, 4, 5, 6, 7, 8. Isononyl is the same as 8-methyl octyl. Can you verify that? It's got the V on the end, which means you can go straight to iso, right? And it better have 9 carbons total. 1, 2, 3, 4, 5, 6, 7, 8, 9. This has 9 carbons in its name. Can you verify that? Methyl and octyl, 1 plus 8 is 9. It's same structure. You draw the octyl first, which is just the chain in the group. And off of the 8th carbon, 1, 2, 3, 4, 5, 6, 7. It's not the 8th carbon of octyl. The 8th carbon of octyl is the end of octyl, Dr. Whitaker. What carbon of octyl was it really on? This is 1, 2, 3, 4, 5, 6, 7 methyl octyl. Ooh, glad we caught that. Alphabetically, this one goes by I and this one goes by M. Just keep that in mind for when we're naming this thing. This does not have a cis or a sec or an iso or a tert pattern. So you can't use it. The methyl's not here for sec. The methyl's not here for iso. There's no short form for this group. Please tell me you prefer isononyl over this. I mean, it's just easier. But this system is perfect. I mean, there's never a problem using the systematic system. That's what I call the bottom system, the systematic system. This is the pattern system, but it's as common as the systematic system. It's acceptable at all times when it's real. You got an iso. This one, I got to go with the systematic system. And that group in blue up there is called a 1, 2, 3, 4, 5, 6. Careful, it's a group. Can't end with A-N-E. But everything else you said was perfect. 3-methyl-hexyl. Remember, parentheses, because that 3 has nothing to do with cyclopentane. That 3 has to do with hexyl. This goes by methyl as well. Oh, wow. What's first, methyl-hexyl or methyl-octyl? Methyl with a H is before methyl with an O. So I'm going to list that first. And the green system has it on carbon 2. And on carbon 1 in the green system was the other one, and that was the 7-methyl octyl. And how do you say, listexia here. Octyl. And how do you say they're both attached to a ring size 5? Cyclopentane at the very end of the green system. That's one name. We're going to come up with 4. What the heck, 4, man? Now, don't move on me. Don't. I know it's annoying when I talk to my computer. Copy paste. I'm going to yank this out of here because this had an alternate name, right? And if I'm lucky, it'll let me move just this piece over here. Why am I having to do all this work? Oh, where's the isononyl in the green system? I forgot. It's 1, right? 1. Green, but the group name was blue. Why did I have to change the order of the groups? Alphabet. Alphabet says methyl, no, nothing to do with a 3. Alphabet says methyl followed by H goes before methyl followed by O. Alphabet says I goes before M. Remember, sec, tert, don't alphabetize these. Don't. Alphabetize. Alphabetize. They don't count. They're like nicknames. You still go by your last name first, right? So when you do alphabetize, use the first letter. Use the first letter here. So for this example, if I don't have a sec on this page, but if it was sec-butyl, it would go by B. That's what I'm saying. If it's sec-octyl, it goes by O. Does not go by sec. If it's tert-heptyl, it goes by H for heptyl, not by tert. And those are 2 out of the 3 things that don't get alphabetized. Please don't memorize what does get alphabetized. There's only 3 things that don't get alphabetized. Sec, tert, and prefixes like mono, di, tri, tetra, penta, hexa, octa, nona. Like when there's 9 of the same group, like nona, chloro, doesn't go by nona, it goes by chloro, right? It's a chloral group. Okay? All right, so the 3 things that don't alphabetize: sec, tert, and prefixes that mean multiples of the same group. Okay. Everything else alphabetizes. So that's only half the names. The other half are the same, except the order of numbering off of cyclopentane was different. Am I feeling lucky? I think I was very lucky. The only edits to be done here are, I'm switching to the red numbering system, where the 1s become the 2s. So this is now a 1, and that's a 2. This is now a 2, and that's a 1. So these are all 4 names are good. All 4 highlighted names, they're not highlighted yet, will get full credit. Highlighter, huge highlighter. How much can I do with one highlighter here? Okay. That's only when you get identical numbering systems back and forth. If it's not identical, if there's any difference at all, then there will be one that's better than the other. The one that has the lower first number or second number or third after you, as soon as there's a difference. Okay. And now we just have a one big ring. You see that in the next one? And this one you can't go wrong because it's the same group. So I'll just use 1. If you go there, you better go 2, 3, 4, 5 here, right? And without drawing every number, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. How do you say an 18 sized ring? Ring size 18. Cycloocta decane. And that's what I promised to later. You just put 2 O's in a row. Cycloocta. There's 8. I need 10 more. Decane. I know I left it way over there, but it's got a couple. It's only got one group. I'm gonna move it. Only got one group twice, doesn't it? So tell me how to name the group first. What is the name of this group? Trichloromethyl. Excellent. That's one thing. Name the group. Now, aren't there 2 identical versions of the same group? How do you show that? What's the right in front of the tri? Don't give me numbers yet. You got to say there's two of this group. Di. If every time you write that prefix that means two of the same group, you need two numbers in front. If you put one number, you're going to lose a quarter point. Okay? Yeah. A lot of students, if they have the same group on the same carbon, think that's okay. If I have two identical groups on the same carbon, like say there was two methyl groups on carbon 5 of a chain, I'll have a lot of students in this room write 5-dimethyl octane. You're losing a quarter point. Where's the second methyl? It's implied. I wrote 5. It can only be on 5. No, you can't invent your own rule. I know you want to. If you have two groups that are the same, they get each a number. Here, it's easier. They're on different carbons. You'll know there's two numbers. 1, 5, right? Di-trichloromethyl. The first di means two of the same group because you have two numbers in front. The tri doesn't have anything to do with number of the group. That's 3 chlorines in the same group. And they're on opposite sides of this ring. How do you say that? Trans. No alternate names here. If you number the opposite direction, you get the exact same name. So, no issues to worry about here. And this guy down here is a bicyclo, isn't it? And this time, because there's new bicyclo rules, you don't have options. You remember what these two special carbons are called? Bridge heads. When you build a bridge, you actually manufacture the bridge heads on each side of the river first. It's kind of based on bridge manufacture. And then you build the steps between them, right? Build the bridge heads first and then add steps between them. That's how the system works. So in the biggest direction, the largest number of carbons between dots, how many carbons are between the dots? Is it the top one? Is it the middle one? Or is it the bottom one? Bottom only has 1, 2, 3, 4 between, 5 between the dots. Top one, 1, 2, 3, 4, 5, 6. Top wins. So your two choices, I'm going to put them both here. We're going to prove one's better than the other this time. The two choices for numbering are in green. Green's unfortunate. We'll use baby blue. 1, 2, 3. So you guys have groups in your mind, right? I know the student who told me to go to the bottom had one reason she wanted me to go to the bottom. There's a group there. This rule supersedes your previous knowledge. It must be met first. That's one method. And then where would 9 be, keeping in mind this other new rule? After you've done the biggest ring, you must go to the next biggest ring next. So where's 9? Bottom or middle? Bottom is a bigger connection. So baby blue numbering would go this way. And where do you think 13 is? You can't call, where do you think 14 is? You can't call this 14 because you already called it 1. So get as close as you can to 13 and do the final ring. That means that is 14. This is too far. This is 14. 50. The other system, you just start with the other dots. Follow the same rules. We'll put it in purple. The other dot, 1. Where would 2 be if your 1 had to be there? You can't make your own rules up. If you put the 1 there, you have no choice for 2. Where is it? Up, down, or middle? Up, the biggest ring first. 2, 3, 4, 5, 6, 7, 8. And then that would go here for 9, right? And then 10, 11, 12, 13, 14, 15. Okay, tell me the positions of the groups in purple since I was there. There's 2 groups. The lower number group is 9. The higher number is 15, right? Is that a 5, 15? Is that a 13? That's a 13, isn't it?
No, it's 15.
It's a 9, 10, 11, 12, 13, 14. It's a 15. I can't read my own writing. That was the whole issue. 9 and 15 have the groups. Do we agree? In the purple. And in the baby blue, we have 14 and 13. Is that right? Put them in the order the lower. Yeah. Which way is the superior way? We know this rule already. This is not an example where I will accept both ways. Blue loses, purple wins, right? Lower first group, lower wins. You got to keep in mind the new bicyclo rules. I'll summarize the new rules. Bridgeheads, one of them has to be 1. Carbon 2 must be in the biggest ring. Once you finish the biggest ring, you got to go to the next biggest ring for your numbers. And the smallest ring last. So purple is the only name we're going to do here. That group on 9, in purple 9, it's a group that's also a ring, isn't it? It's a cyclopropyl. Instead of cyclopropane, which would be the ring as a chain, right? We saw that earlier. It's cyclopropyl because it's a group. Goes by C. It's not on my list of things to not alphabetize, right? I'm not going to add to that list ever. Cyclos count by C. And what's that group on purple? 15. Isopropyl. So what's first, the cyclopropyl with a C or isopropyl with an I? Cyclo. So 9 is cyclopropyl. We'll put it in purple because everything's got to be purple here. 9 cyclopropyl. What's that thing on 15 again? Isopropyl. And you got to use these words every time. bicyclo, bicyclo. Biggest bridge size first. Remember, bridge size doesn't include the dots. Does not include the dots. It's steps between the dots. So I have a 6 on the top. I'm going to count them. The first one's easy, guys. If you include the dots, you get to 8. Take out the dots, it's 6. Like you said, 6. 6 carbons to get to the dot. More dots. And it was a 5 on the bottom, right? Biggest, second biggest, and what's that in the middle? How many dots? Well, they're not dots. How many carbons between the dots? 2. What's 6 plus 5 plus 2? 13. Plus 2 dots. 15. How do you say 15? Pentadecane in purple. We're almost done. Pentadecane, almost done. The groups are on the same side. Is that cis or trans? Cis. Yeah, 9 cyclopropyl, 15 isopropyl, bicyclo, 652 pentadecane. And then we'll do a preview. You don't have to put it as part of your quiz. What is the formula? What is the formula? Oh, I didn't get the 652. They're all one piece. I think the easy thing, pentadecane, right, is to count carbons. Cyclopropyl, how many carbons? Isopropyl, how many carbons? Pentadecane, how many carbons? So we got 21. Is that correct? Nice. Now, no rings, no pi. CN H2N plus 2. And it will not be your answer because clearly we have rings. I know we don't have pi, but later we'll talk about that too. So C21H what? 42 plus 2, right? 2 times 21 is 42, plus 2, 43? 4. I don't believe I just said that. 42 plus 2. It's not 43. It's 44. Cyclopropyl. One ring, correct? Bicyclo. Take a wild guess how many rings? 2 rings. Each ring removes 2 H's. You want proof? Here's proof. That's called butane. It's just drawn really funny. What do I have to do to connect to make it into a ring? I have to sacrifice these 2 H's to make this bond and not make an octet violation. So C4H10 is now C4H8, thus proving my statement. Each ring removes 2 H's. This is totally unrelated to the exercise, but you know, it helps. So how many H's removed by 1 ring? 2 H's. How many H's removed by 2 rings? What's my formula? C21H44 just became H38. Is that right? You lose 6 H's? Answer to the question. Minus 6 H's. Where from? Green highlighter. 2 H's lost for 1 ring. 4 H's lost for 2 rings. 6 H's lost total. End of story. That's an aside.